Alright, hello, my name's Tom. Welcome to the show. Today we're writing more Rust. We're learning Rust. We're doing it by building a simple 16-bit virtual machine. We have a virtual machine. We can load binaries into the machine. Today we're going to write an assembler, and it's going to do stuff. First, let's have a quick look at what we currently have. We have a virtual machine. Let's look at the actual program. Yeah, this is it. This is the program. This is what it looks like. This is why we're going to write an assembler. We're currently writing bytes one at a time and loading them into our virtual machine's memory. This is a program that loads the number OA and FO, which are 10 and 15, and then it adds them together and halts the machine. And when we run it, we get 250 printed out, which seems like it's too big of a number, actually. I don't know what's happened here. What have I done? Wait, oh, hold on. It's because that's not 15, that's something else. What number is that? That's 240 plus 10. Okay. That checks out. Instantly confused, instantly resolved. We've got a couple of things hanging out from last time. Let's maybe just quickly commit these. Yeah, that sounds good. I was meant to clean this all up before. And the last thing we were doing was adding a signal instruction so we could tell the machine that it was done executing. Oh, also, I got distracted and forgot to link this in my Discord. Let's just do that real quick. And then we will smash on writing an assembler, and that's going to go really well, okay? It's going to go really, really well. Wait, am I on the right channel? Fuck, am I live on the wrong channel? No, this is perfect. I almost went live on my gaming channel. That would have been fun. Babu Deli, good morning. Welcome. Thanks for swinging in. Here we go. Here's my link. Okay, perfect. How do I sound? As always, as you're coming in, feel free to sound check me because it's always hard to know if I'm the right volume. You can tell me I can turn up, tell me I can turn down. And with that all said and done, let's smash this assembler. Cool. Okay, well, I remember this commit. I don't need a new branch for this. So, we've got our program set up so that we're sharing a bunch of library code between two binaries. Currently, when we're, our little assembler that we wrote last time, all it does is this. It takes, 2 digits, it turns them into a byte, it pushes them into a binary file. A little bit simple. Babu Deli says I'm audible, thank you very much. Let's do this. So now we're not gonna do this. We're not gonna do this dumb byte by byte thing anymore. We're gonna get each line, we're gonna still split lines on spaces, right? So our assembler input, it's gonna look like this. It's gonna be like a list of files, a list of lines rather. They're gonna be things like, let's pull up our list of instructions as well. That's a good idea. We're gonna clean all this up today as well. So our operators are, and I'm probably actually gonna use the exact name as it appears in this enum for now. I could actually, well, we'll get to this. I've got a lot of thoughts about this, but it's gonna be something like this. So for the program we had before, and then I think this is called pop register, right? Yeah, pop register A. And then whatever signal number I called this. FO, yeah, sick. That's exactly what I said. Except we'll probably actually use different notation for a hex number. So this is the program that we just wrote, and we want to assemble this into these bytes into a file. And this is what we're going to do today. We're going to do this today. Excellent. Cool. So now instead of just turning these into numbers, we're going to have to do something a little bit more clever. And we're also going to be pushing 2 bytes instead of 1. So I do wonder if we can turn this into maybe a vec of u16 and then maybe convert that. Let me stop recording this silly macro. Because in our machine, all of our instructions are at least 2 bytes long. For now, they're all 2 bytes long. Babu Deli asks if this is a custom CPU architecture. Yeah, it's a complete fantasy virtual machine. So I'm just making it up as I go along, basically. I don't have much of a plan. I've got a vague idea of how it's all going to come together. I've written things like this before, and we're just going to see how it goes. So our output, in a sense, is still going to be a vector of U8s. That would make sense. But actually, no. Look, I'm going to keep it as a vec of U8 because there is there have been some whispers in my chat about maybe swapping to variable length instructions. I like having all my instructions be 2 bytes, but there is possibility for more, so let's maybe keep this flexible. We've got a suggestion here from Ratchet. Let me just pop my chat out so I can bring it over onto the screen for notation, which is really cool. There's a lot of cool ways to represent different assembly. This suggestion is to copy 6502, where $ is hex. Percent is binary. Nice. I don't even know if I'm going to do binary is useful in assembly, I guess, right? Because you need to do a lot of masking and stuff. Everything's just numbers. Yeah, that's cool. That's nice. I don't know where hash comes from. Is there an assembly language that has hash as the prefix for it, or am I literally just getting this confused with $? I think I've normally seen 6502 assembly, but yeah, this is basically what I'm thinking. This is kind of what I'm thinking. So for every line, we're going to split it into bits. And then the first bit of the line, right? So this is going to be, well, actually, we don't want to loop over this anymore. We want to say let's call it parts for now. And this is going to be a vec of something equals line.split filter. And then we're just going to collect this into a vec, right? So instead of iterating over it, we're going to filter this out. We're going to get the results back into a vec that we can do something with. Cool. Because, we don't want to do something for each part of this line anymore. We want to look at what this thing is and then decide what the argument is based on it. Excellent. So, if parts len equals 0, then we've got a problem. Then we have a really big problem. We probably want to say panic. Actually, we probably want to say, where do I want to write this as a different function? Probably here, right? Let's go, apparently Z80 assemblers sometimes use a hash. That would make sense, right? I feel like the two assembly things that I see most commonly readable, right? Not counting x86, which is unreadable. Yeah, is Z80 and 6502. If you're looking at like old school game stuff, homebrew stuff. Let's call this handle line for now, I guess, and we'll say op. I don't know. I mean, I'm just going to put more stuff in main for now, and I'm going to see where this boundary kind of naturally shakes out to. If parts len is 0, then we're just going to panic. We're going to do this as simply as we can for now, because I'm not feeling really inspired about where the bits should break out of this, and it's actually going to be pretty simple, so we're just going to put everything in main for now. Once this is all fleshed out in main, then we'll have a clearer view of where the boundaries for where the functions should shake out, what becomes its own function. Actually, if there's nothing on this, if there's nothing on this line, I guess we probably actually just continue rather than anything else, right? That's kind of like saying, hey, this is an empty line. We should probably actually filter x, right? We probably want to filter out empty lines here, just as we're filtering out empty bits between spaces here. So for every part, Babadeli says push from memory address. Push from memory address. I don't know what you mean. I mean, you push and pop into memory. The stack is in memory. It's not one of those funny virtual machines that has a stack that lives outside of main memory because they're convenient but weird. I have like a proper stack pointer that gets moved around. Okay, so we need to do some kind of matching on part 0. So let's say let OpCode equal. Now, this is where things are going to get tricky. I'm going to write some code that will fail to compile for now. And I'm going to write this. Okay. I'm going to write this. So currently this doesn't exist, but we're going to make this. And then we're going to match on what this opcode is. right? If we have opcode, you can add functions to an enum, right? Yeah, you can. I'm pretty sure you can. That should be fine. So if it is push, for example, then we're gonna say, if parts.len is not to or maybe we even just like okay, I'm not going to be as strict. I'm going to write this in a stupid way where you could just have arbitrary garbage after the push. I'm not going to have that kind of gate. That should be okay. Let's say well, I mean, we're just going to return instruction push, and then we're going to have parse numeric parts 1. This needs a question mark here. Cool. And then this is... Okay, so this is where I probably need to wrap this in some kind of function that returns a result. This is a really sensible edge, right? You want this... Because you want this to return either like an okay instruction or some kind of error. But you don't want it to be, like, you can't do this inside main. So this is a good motivation for moving this out into a function. Ratchet says, are all ALU operations going to be on the stack? No, I'm going to do register ALU operations. If you don't know what that means, we'll see hopefully this stream a whole bunch of new operations. That's my goal, but it depends how quickly this assembler comes together. But for now, I've just done a stack-based one because it will be easy for this assembler because it doesn't need to take any arguments. I've kind of picked a set of instructions that only have 1 argument or 0 arguments, whereas add not on the stack will take 2 arguments, and that's just a bit more complicated for the assembler. So, yeah, we're going simple. I've got 7 registers at the moment, which is a few. It's not loads, but it's a few. Cool. Okay, so it's gonna look like this. It's gonna look like this. Now the question is, do I do this all in a function? Maybe, right? Maybe I do all of this in a function. The problem with putting this part in a function is I can't call continue from inside a function. So maybe that's a motivation for a function that takes a vec of parts. So maybe that is it for now. Handle line, it's gonna be a vec of string, I guess, and it's gonna return a result, and the result is gonna be of type instruction string. An instruction is gonna eventually be something that we import, because currently we don't actually depend on anything from our main library crate, which is kind of hilarious. Right, but we're going to depend on instruction and opcode, neither of which currently exist. Okay, we're going to have to define these 2 things. We currently have op, which is an amalgamation of the 2. We're going to split op in half. And we're going to split it in half. If you haven't seen the first part of this stream, we're going to split it in half because of this awful, messy mess. And we're going to unpick that in just a moment. Unpick that in just a moment. Cool. Yeah, register VMs. Ratchet in chat's excited about register VMs. I'm excited about register VMs. Stack VMs are cool, but registers are where it's at. Okay. So we're going to move this up into our handle line. Excellent. This all comes back an indent level. And so now this will be handle line parts. And then we just need to say number, maybe. Raw instruction. encode, yeah, let's say encode U16. So, maybe I can use into or something here instead. I'm gonna go with more verbose names for now. There's probably a better, like more rusty way of doing this, but we'll roll with this for now. So we're gonna turn it into a 16-bit instruction, and then we're gonna output. It's push, right? Yeah, it's push raw instruction, and so we're gonna mask out the lower byte, and then we're gonna mask out the upper. Well, we're not gonna mask out the upper byte actually. Someone very helpfully pointed out that we can just shift it right to the 8, and the junk in the lower 8 bits will disappear, and there's nothing above it, right? It's a 16-bit number. It's a 16-bit number. This name has U16 in it. We don't need to be explicit here. Maybe we should be. Just because assumption right shift 8 needs no mask for U16. Okay, so we'll just be explicit about what we've assumed here. This is a U16. We don't need to do a mask here. But if this changes size in the future, then we will need to mask. And if we have variable length instructions, this will all break. We'll have to be smarter just in general. Cool. And this is good because this means that we don't have to change the type of output. We don't have to do any fancy kind of, I guess, casting. I think you can cast a vector just to like evacuate. Probably that, like, there's kind of a way to do it, I'm sure. So we can just write all, exactly what we put in here. We put in the bytes individually, but the actual parsing logic, the decoding logic, doesn't need to care about any of this. Now, we do need a function that's going to take a string of a number and give us back a result. It's going to give us back a U8. I don't think anything is bigger. Well, yeah, currently because we have 16-bit instructions, we can't have any arguments that are bigger than a U8, so we're going to do this. Apologies again for my janky result types. This is okay for now. We might be more explicit with our results. We might put a more specific type in here than string, but we'll see how we go. Okay, so parse a number. Let's just do this in base 10 first, and I literally had this. It was U8 from radix or something like that, right? Let's pull up a browser and double check. Rust U8 from radix. I'm never quite sure how to say it. From radix. One of those. So it literally just this. S10. And map. We're gonna map the error just into a string. Let's say format. And we're just converting it to a string. We're not doing anything fancy. Okay. To do handle hex binary constants. Binary numbers. Right, so radixes other than 10. Radix 10 here means base 10, like a base 10 number, like the ones we all know and love. Excellent. So this is good. Rather than writing like if parts len equals 2, blah blah blah, having to do this here, let's maybe just have a function. Do I need to borrow this instead of move it? I probably need to borrow it instead of moving it, right? Because if I, like here it's fine. We only do one thing with this vec of string, but when we call this the next layer in, like we're going to call this function probably in every branch of this match statement. So we need to borrow the vec rather than moving it, otherwise it's just not going to be usable. Right, but we're going to abuse a result here and abuse some syntax sugar, and we're going to say if parts len, I've been writing Python, so I want to put the len bit first, equals n, okay. right? So we're going to use result. We're going to use this question mark operator. It's going to nicely collapse this thing into one line rather than having to write this if else statement every branch of the match. We're just going to call this function, and it's going to be great. Format expected. If you have Rust tips for me, please call them out in chat. I fully accept that what I'm doing is probably not very idiomatic Rust, but we'll survive. Assert length. Like, is there a Rusty way to actually do this kind of... Like, is there a standard library function that just does this? Am I being silly? 2, right? So we're basically saying, okay, well, the length needs to be 2, otherwise we'll bubble up an error. That's cool. That's really cool. Okay. And we can also fix this here. We can say format unknown opcode excellent. Okay, this looks good. This looks good. This probably won't actually return an error, right? This will probably... That's also not... That's what this is. Format opcode. Right, so just using OKOR to wrap what will be an optional into an error. This function doesn't exist yet. We're making it up as we go along. We're writing it from the outside in. It's like building an onion backwards. Except now this... What are we saying here? Unimplemented opcode. This is what we're saying here, right? It's not that we don't know what it is. We know what it is. This is where this function returning none is where we'll say, okay, well, that was a garbage string, right? Instead of giving us push, you gave us ps or something, right? And we don't know what that is. Here, this just means that I'm lazy and I haven't written it yet. Okay, so this is good. This is good. This works. We just need to write the other half. And that's what we're going to do right now. So here we have an enum called op. We're going to split this in half. We're going to have a pub enum opcode, which is going to be not push. No, hold on. This is going to be plain data. Oh, and here's add register, by the way. We haven't used it yet, but it does exist. It does exist. And then this, we're going to rename from op to instruction. Here we want to derive debug. And this is the one we want to have represented by U8. So we don't care about the representation of this. We're not going to use it for encoding any information. We're also going to do another important thing here in a second, but we'll get to this. We'll get to this. Actually, no, hold on. Like, I probably actually want to be explicit about what value these have. And let's maybe just 1, 1. Yeah, okay, cool. So before, you know, if I added a new instruction into the mix, if I reordered instructions, for example, it would change the value of their representation potentially. And I don't want to rely on that in my binary format. I want to be explicit about what has what value. So that's good. Let's go. Yeah, so this is going to go. Let's steal this impl. And we're going to say, like, look at, like, this is just disgusting. I don't care about this. I don't want this. I want to say, actually, wait, hold on. Do I want this? This is actually useful for getting the numeric value of the thing, and this is a lot easier. Okay, we're going to keep this value function for now, but we're going to add a function called from stir. It's going to take a string, and it's going to give us back an option of this type. I think using self to refer to the current impl type is good, right? It's less things to find and replace if the name changes. That's good. That's good. Okay, so we're just going to match the string. And it's going to be this stupid op self. nop, push, self, push. There are macros that exist that do this automatically. There are macros that exist that do this automatically, but I don't want to have any external dependencies here. Do I have any external dependencies? No, I don't depend on anything, and I think that's good. I think that's good. And look, I get good typing practice, okay? I get really good typing practice here. Is there really no easy way to get an integer value from an enum in Rust? It's hard, right? Because, well, I mean, this enum, it seems easy, but this enum, it's not so obvious. And I think that's basically why some enums are not just a byte, right? Some or not just an integer. It's like, what does it mean in general to convert an enum into a byte? There might be an easier way. Rust plain data enum to U8, for example. Yeah, okay. Apparently not. Apparently not. But I mean, yeah, so like you can do it, right? You just have to cast it into something else using brute force, which happens to be unsafe. It feels a bit silly, but I think it makes sense given that enum can also mean this. Okay, now the annoying thing is we're gonna have to map from like between these two things. But that doesn't happen. That happens at the edges. That happens out here. That's fine. That's fine. Okay. Okay. So I've got OpCodes. We've got OpCodes. Now. Now there's another step missing in here, right? Because yeah, we parse an instruction into an instruction instead of an op. And we get rid of this awful match statement. This is the most disgusting thing I've ever seen. Although it kind of isn't. Right? Because it's kind of... okay. Now that I've thought about it more, this actually looks like what I... Okay, I'm going to do the minimal change. I'm going to finish my sentences, and I'm going to do the minimal change for now. Where are we? Register. Pop register. Where's our instruction? From U8. Here it is. I could probably do a faster find and replace here, but I just want to do this by hand because I want to make sure that all the stuff still makes sense. This is instruction. Cool. So if you can't see the difference and why this is relevant, it's literally just because, like, you can't just have this enum variant without also initializing it with two registers, which is a little bit cumbersome when you're working with something like an assembler, which actually, you know, we're just encoding this bit often. We're not working with a full instruction. It makes sense to me. I think this is cleaner, and I might even come in and clean this up and make it simpler, right? And just say, I can probably generate some kind of map from this. I don't know. I've got thoughts. But they're not important thoughts right now. That's enough of a tidy up for this moment. And then now this is the easy find and replace, right? Now we just take every instance of op here and we replace it with... Right, and if you don't know how to do find and replace in Vim, it's very, very cool. It's very, very easy. I recommend it. Okay, that's it. That's all we need to do. Except for something else that I've missed. Except for the bit that encoded these instructions. So let's go impl instruction. What did I call the function? Encode U16, I think. And it just gives back a U16. Okay, now this is where I think we can be more clever if we have a good mapping between instruction and opcode, because Has this made it more complicated? I don't know. I just really don't like having to initialize these with data just to get their U8 representation. That felt a bit silly. I think this makes sense. I still think this makes sense. The other thing is to just not have this type at all, right? And let the instruction type just be like a struct that has an opcode. Yeah, exactly, right? Like optional register, like rather than having one thing, struct, maybe that looks like this. It has an opcode, and then it has like, but then it's hard. You'd either have, like option register R1, option. Like this feels gross. U8. Right? Like this is all the things that instruction might have, but then decoding and using this for each instruction, for each opcode feels, I don't know, like this is cleaner. There's just a gross mapping step the way I've done it, which is tolerable. So what I'm kind of saying is you would go let op equal maybe like self even self.toOp. And no uncertainty. These map 1-to-1. This is okay. So we have an opcode, and then but we'd have to match every single thing. Okay. This is okay. This is okay. Let's take a different approach. Let's take a slightly different approach. If it's a NOP, then we just return 0 every single time. Well, actually, no. If it's a NOP, then we return opcode NOP dot value. If we have push x, and this is the value of defining instructions with their data in the enum type like this, right? Because now we know we have everything we need for a push instruction. So this will be opcode push value or x left shift 8, right? And actually we can kind of do this in a dumb one-liner, right? This is how this instruction gets encoded. Now, manually writing this out for every instruction feels wasteful because it's going to look similar. It's going to look really similar. Pop register R is going to look really similar to this. Opcode pop register value or. Now, the register we can also get as a U8. Oh, hold on, no, wait, whoa. I don't need this dot value method. I can use as U8. Okay, sorry, I lied before. This is easy if we tell it it's a U8 and it's just a plain enum. This is easy. Also, that is pub, that's good. These need to be pub functions. This is a pub. Value, get out of here. Beautiful. Okay. Did I? Cool. As U8. I just wrote as U8 somewhere and I've kind of lost it. Maybe I undid that by mistake, but I hope that doesn't come back to bite me. As U8. Right? So this we're just going to return as a U16, right? We're going to cast it hopefully via U8 all the way to U16. Hopefully Rust can do that. But here, I think this has the right. Look, this might be trying to grab all of this as like it might be thinking this is all the type. I might need to bracket this maybe, but we'll try not to bracket it first. Now the register we're gonna say as U8 but then we're gonna mask it to be 4 bits because it should only be 4 bits. And then we're gonna right shift it. Okay. Now, this is good. This doesn't have any type, so this is just opcode add stack as u16. This is good because the way we're going to write this statement, we're not going to have a default at the end. We're gonna handle everything. Okay. And the advantage of handling everything manually is that if we add another instruction, then this will yell at me for not having done the mapping. Let's have a look at what's going on in chat. C is much easier in some cases, even with the shotgun. Correct. C is much easier, but I have had no debugging dramas with Rust so far, which has been cool. I always have some dumb debug pointer thing in C. Rust just front loads a lot of the pain, I find. Like, C becomes painful the longer you work on a code base. Oh. You remember learning Rust with a chip 8 emulator? That's cool. Having to manage overflowable registers manually, that's not cool. That's hard. That's big brain stuff. Am I using U8 because of bit width instead of U16 instead of bit 8? U8 because of bit width, yes. I fell over that a lot reading it, even though it's very plain English, but yes. These are 16-bit instructions. We're casting them to U8 sometimes because we're combining them with other things. They're only really U8 values, but in the case of like an add stack instruction, the lower 8 bits is the entire number, so we just want to cast it all the way up to U16 and fill the rest out with zeros. I don't want to think about it. In this case, now, it's tempting to try and maybe write some kind of like, some kind of helper function for this, maybe, that does this. Okay, now don't, like, this might get a little crazy, okay? This might get a little crazy, but we're gonna say R as U8 and right. So rather than having to write out this bit math every time, maybe we can just do the simple thing. Oh, this gets, yeah, left shifted by 8. This gets left shifted by 8 plus 4, which is 12. Encode. And then this is just U left shift 8. Cool, okay. We might have issues ORing a 16-bit number with an 8-bit number. I'm not sure how Rust is going to deal with this. But yeah, let's make this a little... I don't know if this is really simpler. I'll just try and make this register. I'll just try and make this a little bit nicer for me, so that I don't have to duplicate as many silly things. Cool. And so this is then just encode R1, R1, or encode R2, R2. Excellent. Encode. And I've just put this in this kind of namespace so that it doesn't pollute too much. I hope that's okay. It feels a little gross maybe, but we'll survive. Okay, cool. Excellent, excellent. Is that everything? I don't know, this might blow up and yell at me when I try and actually run anything. We'll find out, we'll find out. Cargo build. Excellent. This is good. This is the Rust pane. Cargo build, cargo build. Do I have plans for how far I want to take this assembler? All the way, all the way. No, I want it to be able to assemble simple programs. I want it to maybe have a couple of utilities for metadata. Scopes, macros, Yeah, look, macros would be fun. For, like, today, it's going to be very basic. I want to have a more functional virtual machine that has more than like 8 instructions before I get too crazy with the assembler. But it would be fun to dive in and like do some macro stuff. I have written a macro assembler for a simple virtual machine I'd written in the past. So yeah, I would definitely do it again. I've done it in Python before. I would be interested to see how much more complicated it was in Rust, but it would be a good challenge. I just need to live stream more often so that I get through these a little bit quicker. Excellent. I have an entire word. Where is it? Where did we go? It was in vm.rs, and there was a match statement that did not have anything with it. This. Match S. Okay, good. Good. Push X not found in the scope. That is because this needs a self before it. Okay, so I'm gonna write a macro to do this real quick. Okay, cool. So excellent. Again, learn your, I want to do this in Vim so that I can scroll around. Learn your macros in Vim. They're super useful for stuff like that. Expected U16. Okay. So somehow left shifting a U8 by 8 gives us... Okay, so this is easy. This is actually really easy. We just want to tell it to cast it all the way up to a U16 before we shift it. And in general, right, like, what does it mean to left shift a U8 by 8 bits? What does it mean to left shift a U8 by 12 bits? Is this just 0? Like, it's kind of nonsense. Always, before you bit shift, cast up to the higher type, because you don't want your compiler to have to guess, because it'll probably guess wrong. And again, as U16, literally the same thing I just said, but I still ignored it. Encode 52. I really need to fix... I need to fix my quick fix list for cargo build errors, because it just does not work. This is just text. This is plain text. Variant or associated item pop register not found in instruction. Excellent. Register instruction. Pop register. Pop register. There it is. Typing is hard. Spelling is hard. How's everyone's evening going? How's everyone else going today? Because I'm having one of those days where spelling's hard. Excellent. Encode num. Expected U8 found a borrowed U8. VM58. X is borrowed. Can I just like smash that down into the real world? Does that work? Ooh, expected U8 found U16. That's even better, actually. That is even better. Oh, wait, no, that's... Wait. Okay. I have made an error. These all need to be cast to U16. This is literally the thing I was just saying. Cast to your widest type before you do bitwise maths. Ratchet is trying to write an assembler for C for a while now, alongside some plans for instruction set. Not a lot of resources. Yeah, I don't think anything is too crazy. Oh, you're doing all right. It's about 1 p.m. You have an exam tomorrow. What is the exam on? Is it a programming exam? But yeah, time zones are always weird. It's always tricky. But yeah, I don't think anything is too crazy in assembler world, right? Macros are fairly straightforward. They work the same way as macros do in other, C-like languages, right? You just take a bunch of text in and then you dump a bunch of text out into the file. It's not, like, most assembler macros are not very complicated. I have dumped some things where it does not belong. Pop register. I stray 8. Okay, so what's going on here? Expected register found. This is just annoying. These are borrowed because of something. Blah blah blah. But because they're like literal data, like they're just plain data types, I don't think it's a big deal to just dereference them like that. Algorithmic analysis class exam. Only 2 more exams and the semester's over. That's very exciting. Also weird for me, because my semesters always ended in kind of like June and then November. Like my uni year would start in late Feb, early March, and run until November, and then we'd have summer off. And I guess it's different for you guys that have winter in January. But you know, in Australia, you knock off in November, you enjoy your time out in the sun, then you go back as the weather starts to cool down again. Just kidding, it's somehow still 40 degrees at the start of March because Australia gets you every time. You think you're out of the woods, and then it's still really hot. Okay. Now this is annoying, right? This is annoying because I don't want to have to write into everywhere. Can I do that? Does that work? If I just put a borrow there, do I not have to worry about this? No, okay. Rust string to stir slice. Yeah, you start your summer semesters in mid-February. Yeah, I don't know. It's just really weird. Hemispheres, man. I can't even do it. Okay. String dev ref. Oh, okay. Let's maybe just do this. Dot as stir. And now we don't get any of these yelling at me. Okay, option self expected, option opcode. But we just got opcode because this was a non-exhaust. Ooh, no, that doesn't work. None. We need to add just the none option. Except then I still need to go, okay, we're gonna write another macro. Ready? So we're gonna go to the start of the line, we're gonna go back a bit, and we're gonna say, okay. Okay, now let's see if this works. It does. If I was a smarter man, I might be able to like write a smarter thing that did that without a macro, but I like the simple things sometimes. Okay. Oh. I am still in result land, not option land. Okay, method value not found for this enum. Yeah, that's because 103. If x equals... Let's see if I can do this without the dot value. Let's see if I can just compare these things. I probably can't. I'm probably going to need to write stupid lines in here. Yeah. If x equals... Wait. This is silly. I should just be matching against this. Now that I can just convert op freely. The problem with trying to convert this 8-bit number into this type was that you can't do it, right? You can't just do that conversion because depending on what the thing is, you need additional data to actually instantiate the enum variant. But here, we can cast this thing into an opcode. We can do that. We understand how to do that. It's not pretty, but we can do that. Now, how do we do this? Rust cast u8 to enum. We have to write it ourselves, right? Because Rust can't do this automatically because this isn't exhausted. This doesn't have a value for every u8. We need to define what this mapping is. And we can do that. From u8. B. We'll call it B for byte. u8. Option self. Now this is where we do this stupid thing, but it's going to be nicer. X do we say, what was it? What did I literally just have? What did I literally just have in this file? I forgot. X if x equals this dot value, yeah. X if x equals self nop. Again, this feels like code that probably is better served by a macro, but, you know, we'll just find and replace for now. Nop push. We want it to be this. Okay, nop push g, nop pop register signal add stack add register none. Okay, there we go. So we have a mapping from U8 into our op type. So everything we add is gonna just be a shitload of annoying things we have to like map around. Like every time we add an opcode, we're gonna have to add a new encoding for it here. We're gonna have to add a new corresponding instruction, a new encoding, a new thing here, a new thing here, a new entry here. And actually, yeah, we don't want an default case anymore, right? We want this to be exhaustive. Because if we have a default case, then, you know, if we don't have a default case, right? So if this is here, if we add a new opcode and we don't handle how to parse it into instruction, we'll just get an error if we encounter it. But if we delete this, we get a compiler error. We don't need to wait for it to pop up somewhere for our tooling to complain. Rust, the language, will tell us that something's gone wrong. Okay. Expecting tuple struct or tuple variant found uint variant opcode pop register. Use this syntax instead. Oh, yeah, well, that makes sense. Because you don't have this bit. You don't take data with it anymore. It's just the opcode. It's just the opcode. This expression has type U8. Opcode nop. Except U8 found opcode. Match op. 115. This expression has, oh yeah, because I want to say opcode from U8. Okay. Or, so we just need to wrap this in an error that then says unknown, unknown op. Okay. So we take the option response, we turn it into a result, we unwrap it using the magic question mark syntax, and now it just gives us a different error. Pattern. Okay, well this is good. This is what we want. This is telling us that we have missed things. So in VM, at line 56, we have missed a mapping, and that's good. We want this to yell at us. So instruction, what did it say? So nop push pop register add stack add register signal. We haven't covered signal. Self signal x opcode signal as U16 or self encode num. Excellent. Move occurs. Okay, register doesn't implement copy. That should be easy. We can just derive copy for an enum like this, right? Because there's no freaking data in it. Like Rust should be able to work out how to copy it. Rust should be able to. Clone is not implemented, is required by copy. Can we say clone and copy? Is this okay? This is apparently okay. Ratchet says 12 weeks of work, then a month for exam season. Yeah, that sounds about right. I think 12 week semester. Sounds about right. It's been a little while since I've done this. Okay, it's telling us that we've missed another thing, which is good. This is what we want. We want the compiler to tell us when we need to do work. And of course, opcode add register. We didn't cover this last time, right? We just didn't. Reg1 is excellent. Cool. So we decode this register similarly to last time. Let's even maybe just do this in line. Hey, let's say ins and 0xFOO right shift 8 as U8, okay, or blah, 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 blah. And then we do the same, we unwrap this as a result, and we do the same thing for register 2, except register 2 is in the top 4 bits, and we need to right shift it by 12, but that's fine. And now we have 2 registers, we know they're valid, and we say instruction add register, reg1, reg2. Delightful. Okay, now what do we say? Register expected one of. It's because we missed an equal sign. Not only did we miss an equal sign as well, we try to redefine reg1, this should be reg2. Okay, nice, we're moving forward. We're moving forward with more errors. This is good. Okay, or because we need to actually use the variables that we've used in the scope of the function. Okay, this still isn't found. Because, okay, well this makes sense, right? This we want this to be this thing, but we don't want to copy and paste this. Let's go, reg1, let's call it reg1 raw is, this is what I literally had before. I got rid of it, I wrote it out, and now I've decided I want it back. Fight me, it's fine. Right shift it by 8. Reg2 raw is ins, mask out the top 4 bits, right shift it by 12. Okay, now reg1 raw, and we want to print the raw value that is going into register 1. Reg2 raw. Excellent. Okay, now this is good. This is looking good. We're getting closer. We're getting closer. We need to wrap this in an okay. Okay, we're moving forward. We're moving into the actual assembler now, which is great, which is fantastic. This is all workable. This is all workable. So we're in the golden file now, the file we actually want to run. This we've seen before, right? We've got a string, we want a stir. Found, yep. So when we call assert length, we need to actually borrow the vec rather than just passing it in. This is all good. Unexpected argument of type opcode. Expected string found stir. Oh, yeah, well that also makes sense. This should be format. We're just like not using things as they actually are. Opcode cannot be formatted with the default formatter because I just wanna crap it out there. I don't really care what it is. I'm just gonna use the debug formatter, that'll be fine. Method not found in result because the line is not a line. The line is in fact a thing that is like a line. We want line. Wait, hold on. This isn't even the line. This is the, is it? Buffer reader. Alright. Lines filter. Why has this changed? I didn't change this. Oh, I did. I did change this. Okay, we'll just get rid of it. That's fine. That's fine. Actually, let's not even just get rid of it. Let's just say if line inner.len is 0, then continue. Right? Basically the same thing we're checking down below, but we're gonna early out here. Expected vec string if parts.len is 0, 58. Oh. I should be able to, collect should know how to handle this. Or not. Apparently not. Okay, let's change everything to just use stir then, that's okay. That's okay. This is fine, this is fine. Handle line. That's phenomenal. That's all actually better than what I wanted it to be. Now here, it's a bit more annoying. From stir. Well, yeah, what am I saying? Let's just bubble up the stir even further. This is better. This is literally just better. Use string slice as far in as you can, right? This is just way better. Expect U8 found U16. Yes, yes. This also makes sense now that I look at it. What did it say? Line 61? Raw instruction. So, you know, we're masking out the lower 8 bits, but Rust isn't smart enough to see here that a 16-bit number with the lower 8 bits, like with only the lower 8 bits masked in, is just a U8. So we need to be explicit. We need to be explicit. And that's okay. And there we go. Okay, it builds. It builds. Holy crap. Let's take this file and we're going to recreate it. So we're going to say push 10, push 240, I guess. And then we're going to say add stack. And then we're going to say pop register A. What am I... Well, I mean, most of these things aren't implemented, but that's okay. We're just going to run it first, and then signal, what did I say? I think it's signal 15. Excellent. So what happens if I run this? Cargo run bin ASM unknown. Oh, right, yeah, because I used a comment here that is not implemented. And it gets through these first 2 pushes, but then it hits an opcode we haven't told it about, and it dies. So that's cool, that's cool. That's really cool. So first things first, let's just handle comment lines because they're important. If line 0 is this, we can probably put an or here, but let's just like do this first. I think this is okay. Can I convert a value of result string? Line.get 0. Maybe this. Oh, hold on. Line. Well, that's very silly. Line inner. I keep forgetting I've got 2 line variables because one of them's a result. What the hell? Why? Okay. Let's change this to get. And then this should work, I think. Get partially q. What is going on? Why can't I... What does this mean? Ranges of usize. Does this mean I have to say like this? Except now it's a string. Okay. There's definitely a better way to do this. Is it like... I don't know, whatever. Rust fans, please yell at me in chat. Stir. What the hell? Okay, Rust test first character of string. Someone else has had this problem before. Someone else has questioned this before. How do I get the first character out of a string? How do I get the first character out of a string? What is going on? Why is this so hard in Rust? Surely I don't have to collect. Cars next unwrap. Cars nth. Okay, that's even better. That's even better. Let's go. There's a reason Rust is like this, by the way. It's because this, like, this thing. What is this? This is a slice of string. What is the first index of a string? I don't know. It kind of makes you be explicit, I guess, that you care about characters. I think this is my understanding of it, and it's probably a half truth, as many things I say are. Okay, so if the first character is this comment character, then yeah, just keep going. Okay, nice. We ignore the comment now. We hit an unknown operator add stack, which is here. So this is where our error is coming up. So we just need to implement everything else that's missing. Add stack. We'll insert length. Right, so this just has one thing, and we're just going to say, okay, instruction, add stack. And that's it. It doesn't have anything in it. Okay, now the next thing, apart from apparently not closing this, not even opening this block properly. Now we hit the next thing that we haven't implemented. Pop register. Assert length, parts 2. Right, this has 2 things. Okay, instruction pop register parse register. Cool. So now, of course, we're missing this parse register function. We need the function that takes a string and gives us back a result register. We're going to pull in register from here. I don't think I already have a function for going from string to register. I don't. I have one from going from number to register, but I want to go. I want to go from string to register. I think that's a lot better. Okay, so let's just go match S A. Okay, register A. And if we have anything else right now, we only care about the A register, we just get error unknown register. Okay, this is okay. What happened? Register. I still can't spell. Today's been a long day. Register. Did I just forget to... Register. I need to actually read what that error message said. I didn't read it. Cannot be applied to type stir. That's actually very easy. That's very, very easy. This is just me putting a question mark in the wrong place. It has to go outside the bracket. Now it builds. Now it runs. Now we're down to our last unimplemented thing. And then it's going to work. And it's just going to work first time. We're going to get the same result. The program will be fine. Right? And I'm actually pretty confident when I say that. Usually when I say stuff like that, like it's going to work first time, I'm just kind of memeing. But I think here it's actually pretty true. Because I've had all these compiler errors that have warned me. They've forewarned me of dangerous things. I'm feeling quite confident. Okay, run. Not quite. Signal. Oh, right. Yeah, signal has a thing, doesn't it? Parse numeric parts. Oops. One. I just changed my keyboard mode. Hold on. That's always stressful. It makes like a very melodic bleep, and then you're in call mark. Okay, that's also good. Signal takes two things. Okay. Now let's run the machine. prog.bin. Unknown signal OF. Okay, that's good. I think. What signal? Oh. I was calling signal OF. I want signal FO. So, well, I mean, look, like we're getting close, but let's just throw a spanner in the works again. Let's go. I don't want to have to work out what these numbers are in decimal. Let's go. What did I say? FO. Right? Like, I can do this. This isn't going to be complicated, is it? There's no way this is going to add much complexity. Okay, so let the first character, so if s len is 0, then this is just an error, okay? This is just an error. String has no length. Otherwise, the first character is s.chars.nth 0.unwrap. We could I guess we can, I don't know, I'm just going to unwrap it because we've already done this and it's fine. This literally is never going to fail. Famous last words. If maybe match, what do we want? Let's say radix and let's say number radix is. So depending on what this first character is, right? If it's dollar sign, then we're gonna say the number is s1 ... and the radix is 16. If it's percent, then we're gonna say S1. I don't know if we can just do this unbounded like this. We will find out shortly. Our radix is gonna be 2. Otherwise, we're gonna take the whole string and our radix is 10. Maybe I have to wrap this as a tuple. And I think this needs to get wrapped as well. Okay, cool. So this is a cute way of doing it. Then we don't have too much duplication. Num radix. Let's see what happens when we run this. That's not the right thing. Here we go. Okay. Stir integer found. This is type stir integer. Expected stir integer found. This, why is this, okay, hold on. Can I just borrow this when I slice it? Is that okay? Is that gonna work? I'm confused by why this is just a stir. 19. Oh, okay, well that's okay, that's okay. Now when we run it, we get the right answer. Holy shit. That was a journey. That was a freaking journey. To write a very simple assembler in a language I don't know. That really took us somewhere. Yeah, it really took me through the ringer, but that's okay. That's good. It was good to go on this journey to get here, right? It works. So let's take this opportunity to add. Well, first off, okay, let's commit. I'm gonna write an awful commit message because I'm tired. And then let's go in and let's try and add a new instruction. I need to split some of this stuff out to a new file as well. I might put the register in its own file. Okay, let's do that while I think of it, right? So let's put register in its own file. Source register. That, I don't know what that link was. Holy crap, that's dangerous. Oh, that's the link to this stream. No one click that just in case it's a shady link. Okay, so we need to go into lib pub mod register and then we'll put the instruction and op stuff in its own file as well, just because this file is getting a bit long, a bit cumbersome to navigate on the keyboard. Parse instruction arc, that's all good. Okay, so let's go source, let's call it op.rs because that's a cool name. It feels very sleek. And then we go back to lib and we say pub mod op. Cool. Now this should still run when we try and run the machine. Except we have missed, of course, we need to now cross import things. Ratchet says that was a lot of progress in a relatively short amount of time. Thank you. It felt like a very long time, but that really does make me happy to hear people say that. I always am very harsh on myself, so it's good for people to give me a bit of hype. Create VM register register. That's what I want. Oh, wait, but where? Hold on. I guess maybe I do have to do this. Maybe internally I have to. Oh, I guess if I'm referencing it by the crate, I can't reference, because in lib.rs I kind of export this out so that things importing simple VM don't have to care about the inner structure, right? They just get it all. But I guess here, because it's within the crate, I still have to be explicit. Does that make sense? That makes sense to me. I think that's okay. VM.rs. Yeah, cool. Okay, so VM.rs, we have to do a similar thing. Use crate opcode and instruction, and also use crate register. No register in this root. That's weird. That's weird. I thought that was okay. I thought I'm doing basically the same. Oh, wait, hold on. It's because I'm, like when I actually include these. Here I'm including them from the like, I mean, these are different parts. Ready? Look at this. So simple VM : machine and register. This works. Simple VM : no, that does work. I didn't mean to quit then. What the hell? Simple VM register's not in this root. Similar name exists. But I shouldn't have to import it. Like, okay, look at this. Ready? Lib.rs. Oh, no, I'm silly. Register. I need to just re-export all of the things. That's okay. Now yeah, that was me. That was on me. It all runs. It's all fine. Okay. Let's move types out of vm.rs. Okay, now let's add a new instruction. And let's see what the process looks like, because it shouldn't be too bad. So let's do, what's a good instruction? What am I missing so far? So I have stack operations. I mean, I don't have any jumps, but I think jumps are going to be a whole stream of their own. Let's do subtraction. Let's do sub. Oh no, let's do. What's fun? Maybe let's do push register, right? Let us get a value from a register back onto the stack. That's kind of cool. And then we'll put it here. Try and keep these in order. Now if I cargo build, I'm going to get a couple of errors just because I've added types and our non-exhaustive patterns suddenly yell at us. And this is good. This is exactly what we want. We want to be guided by these errors. So on line 18, so in this, we need to add in vm.rs, line 18, we need to handle it here. Okay, so when we parse an instruction, well, we need to know how to parse it. Let's say opcode push register I really need helpers for this because I'm just going to write this so many times and it's going to be ridiculous. Okay, so we get the register and we're going to have push register. Nice. Now what happens when I build? I expected this, found register because we need to put a semicolon there. Now we have on line 106, that's good, 106, match op. So when we actually run the machine, we need to know what to do with it. Instruction pop, push register. Let's say self.push, self.registers as usize. This needs a thing, and then we just say okay. And now in op.rs line 32, we need to add an encoding for it. Self push register as u16. And then we have the encoding of the register. This is a lot of typing just for a new instruction. That's okay, that's okay. And then we have one more on line, wait, what did this say? Push res gith, fuck, every time. I'm trying not to swear in this channel. Register. I'm trying not to swear on this channel because I want it to be a little bit more, like it's not kid friendly, but I want it to be more kid friendly than my other one. And then this was wrong, encode R1. Result that must be used. Oh, right, yeah, of course. So now we just have to put a question mark on it. That's good. Let's then... Okay, so we end up with this thing in A. Let's just flesh out our test program a bit. So we end up with 240 in A. So then let's say push register A. Let's push it twice. Add the stack. Pop register A. and then end. So let's do a smaller number just so it's easier to keep our head around. So we'll have 21, so we should end up with 42 as the answer, right? We should be doubling it. So we need to cargo run ASM. Okay, push register unknown. This is interesting because I thought I said that we would, oh, it's because I put this, right? So let's get rid of that, right? Now when we try and run it, it actually tells us that we're not exhaustive. This is what I actually want here. So we're going to copy and paste. And again, like it feels like a lot of this could probably sped up with macros, but for now I'm just going to be explicit. Instruction, push register. Like I'm just going to keep it simple. Like who cares? Who cares if it's not as smart as it could be? Opcode not handled. We're not even going to assert the length for that. Screw it. And then we also need to handle add register, I guess, right? And now this is going to be more complicated because this is going to have parts. This is going to have a length of 3, which is pretty crazy if you ask me. And then we're going to copy and paste a little bit more. Add register. Cool. Excellent. Okay. This should work now. This will just work. Push unknown opcode, push register. Unknown opcode, push register. Have I made a typo? Push register. That's okay. So we want to go back to op, push register. Now this one's more complicated, right? This one's easy to forget because we're just like you just can't be exhaustive because there are many possible strings. Maybe not infinitely many because there's some upper limit for how essentially there are within the scope of the world as we think about it, there are basically an infinite number of strings as far as that's concerned. Unknown op 3. Okay, now we have an unknown op. And that is also complicated because that also shouldn't happen, right? Like, what does this mean? Unknown op VM opcode from U8. So we're decoding the opcode from U8. So this is also tricky, right? Because it's easy to forget. So I guess this hasn't been the panacea I hoped it would be. Attempted to subtract with overflow. That sounds like a stack problem. That sounds like a big stack problem. Let's go to vm.rs 81. This is going to be, within... Was that 81? What did it say? 83. 83. This is literally... register SP... Okay. Maybe it's... Well, no, it shouldn't be the memory read, should it? Maybe it is actually just the register. The stack pointer... Okay. Maybe we need to just do better, like, dumping of our machine state as we go. And this might actually be a fun thing to just quickly do, like a function that's going to dump our all of our registers. Let's just call it state. It's going to borrow our self, and it's going to give us back a string. And can we say... This is just going to be a long string, right? There's got to be a multi-line string literal in Rust, yeah? All literals... Oh, perfect. This is just how Rust works. That's redundant. Okay, so A, B, C. What are my registers called again? I can't even remember. I'm getting very tired. I'm just gonna push through a little bit more, and then we're gonna sleep well tonight. That's not what I want. Register ABCMSP CM SP PC BP flags yeah, that's enough. That really is enough, I think. So then we just have this is going to be really annoying. Or maybe even I just say like self get register a let's try and make this as not tedious as possible, but that sounds like a tool ask because it's just gonna chew up a bunch of time. MSP PC BP flags. That was too many things. Cool. This needs to be indented more. Nice. Okay. This needs to be indented even more. Okay, there we go. That's perfect. That's absolutely perfect. Now we're going to go into the binary that runs the VM, and after every step we're going to say println vm.state. Okay, we can't print this thing. There's got to be a better way of doing that that's less silly. Okay, this is good. This is good. So actually, maybe I want to print the state before I do anything, because then we get the program counter at the correct place. So A is 0, the stack pointer is 0, 2, 4, 2, 0. So stack pointer 0, program counter 0, 2, 4, 6, 8, and then it crashes on 8. So test 0, 2, 4, 6, push register. Why are we blowing up at push register? Okay, why is pushing a register causing us to somehow, because the stack pointer starts at 0, right? So it's A3. That's, yeah. Oh yeah, right, no, it'll move. Pop. But wait, we shouldn't be popping, should we? What's happening is the stack pointer, wait, hold on. Why is the stack pointer 0? That's not right. The stack pointer should be not 0 because our program starts at 0, right? Why? Oh no, this is not good. This is really not good. I've made a glaring oversight. I've made a really glaring oversight. When I initialize my machine, where is it? Machine new. Yeah. Yeah, I should probably set the stack pointer. Let's go pub fn set register. And we'll say self.registers r as usize equals v. That's all going to be good. Then we're going to jump back. After we make the machine, we're going to say set. We're going to remember to write the keyword mute because this is a mutable thing. Set register. We're going to do register. We're going to set the stack pointer to maybe 1000 just for now, just as a random number. Because that should be okay, right? And then if we run, our stack pointer is going to be in a better place. That's good. That's good. So 21. Interestingly, after we push to the stack, it appears, so this increases and then decreases 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 and then decreases. Have I implemented the instruction wrong? Push register pushes. Why do we continue? I have a suspicion. As to what has happened here, okay? This code for push register is never getting called. What's happening is we continue to pop the register every time we call a push register instruction, right? Because we expect this to go up, up, down. Now we've popped into the A register, but the next instruction should be a push. We should go back up to 4100. We should go to 4102. We should go up, but we don't. And we don't because the instruction is being mapped wrong. So let's look for pop. Let's look for pop. Let's look for pop register. Okay, so that's good. That's mapping correctly. It must be in the assembler. Pop register, push register, push register. Yeah, that's okay. Op.rs, pop register, push register, push register. Push register has a different number, that's good. This, see? We're converting it from a U8 into a thing, and I forgot to update the mapping, so it did not become the correct thing. So this is quite prone to human error. And now we get the correct answer of 42. This is all quite prone to human error. I might need to do something about this. Okay, this might be a case for macros. I might have to do some thinking about this off stream and work out what's going to happen. But for now, I mean, look at this. Like, this is kind of cool, right? We can write... where did I go? We can write some fairly cool looking programs. We can use different formats for our numbers, right? It all just works. You know, there appears to be a bit of interest in maybe seeing me write a macro system for this. That could be fun, but that's really just string substitution. It's nothing too crazy or complicated, you know, all the little bits. It would be fun to maybe have some directives of, like, you know, you could maybe just have like some binary blob data such as this in line with some directive, and then swap mode back to ASM and have normal instructions. You know, maybe that kind of thing would be cool. But yeah, this is a program. It adds two numbers together, then it doubles that number, and it halts the machine. And that has been quite a journey to get there. Holy crap, you know, it's always the little things when you're learning a language that's brand new, right? You're always working out how stuff works as you go. But that's been a lot of fun. That's cool. We can see our machine state a little bit more detailed. Hopefully it's not going to be too long before we can make this do more interesting things, start to, you know, maybe rig it up to some kind of graphical display. That would be cool, a virtual graphical display. My goal is eventually to get this running in a web browser with WASM. So as much as I say no dependencies, there are going to be a crap load of dependencies to get that happening. But this has been a lot of fun. My name's Tom Marks. This has been a fantastic Rust programming live stream. Thank you to everyone who's been watching these VODs live and on YouTube. Thanks to everyone who's been hanging out. Ratchet, good luck with your exam tomorrow. If you're still here, go study. Okay, it's enough YouTube. But yeah, thank you all so much.